Hey guys, Mr. Gran here, 8.2 multiplying and dividing rational expressions. In this video, we're going to be talking about dividing rational expressions. All right, so our steps for dividing, well, it shouldn't say dividing polynomials, it should say dividing rationals. But very similar to how we did multiplying with one extra step. We're going to factor all the parts completely, then we're going to keep, change, flip. So if you remember how to divide fractions, if we do 3 over 4 divided by 1 over 2, how many halves fit into 3/4? We can do this using keep, change, flip, right? What that means, keep, change, flip. We're going to keep the first fraction, 3/4. We're going to change this to multiplying, and then we're going to flip the fraction, the second one. This is also called multiplying by the reciprocal. So then now we can just multiply across the top, right? 3 times 2 is equal to 6. 4 times 1 is equal to 4. And then this is a fraction that reduces to 3 over 2. Okay, so once we do the keep, change, flip, then we'll cancel our common factors, and then we'll multiply across. So once we do the keep, change, flip, then it really just becomes a multiplication problem. Okay, so a couple of examples to start. This would be our exception to the rule again, because we're not really factoring this, so just like with the last video with the multiplying one. I'm going to start by doing keep, change, flip. So x squared over 4 times, and we'll flip this fraction. We'll multiply by the reciprocal, and then x to the 4th over y. Now I'm going to combine it into one fraction, and then I'll reduce it. So x squared, so the top is going to be 12x squared y squared. And the denominator is going to be 4x to the 4th y. And then just like last time, once I get it to this point, I want to think about reducing each part separately. 12 over 4, 12 is divisible by 4. 12 divided by 4 is 3. X squared over x to the 4th, the 2 on top cancel 2 from the bottom. And then y squared over y, this y cancels 1 from the top, so it's 3y over x squared. All right, one like this. Again, we want to start out just by factoring it. Factor one piece at a time. Two numbers that multiply to negative 15 but add to 2 are going to be plus 5 and minus 3. Two numbers that multiply to negative 5 but add to 4 are going to be plus 5 and minus 1. Difference of squares, plus 2 minus 2. And then GCF. Both 7 and 14 are divisible by 7, so 7 times x minus 2. All right, now if we do keep, change, flip, when we rewrite this, the first one is going to be plus 5 minus 3 over plus 5 minus 1. And then we'll flip the fraction, we'll multiply by the reciprocal. So that's going to be 7x minus 2, right? The denominator is now, since we're doing the reciprocal, is now the top. And then our difference of squares, plus 2 minus 2, like that. Now I can just start canceling my common factors on the top and the bottom. Plus 5's cancel out, minus 2's cancel out, and everything else doesn't match. So my final answer, 7 times x minus 3 on top, and on the bottom, x minus 1, x plus 2. And just like with multiplying, we're just going to leave it in its factored form and call it good. And we're also going to assume all expressions are defined, so we're not going to worry about domain restrictions. All right, if you want to pause the video and give these a try, and then resume when you're ready to check your work. All right, so this top one is a little bit trickier. It's got some two-step factoring to do. So if I look at this, I can tell right away it's a not a difference of squares, it's a GCF, right? X to the fourth and x squared, they're both divisible by x squared. Now I've got a GCF, or I mean a difference of squares. So x squared, and then the x squared minus 9 is x plus 3, x minus 3. So I'm going to cross that out, I'm going to cross that out. That's my factored form of this numerator. This one multiplies to 3, adds to negative 4. That's going to be minus 3 and minus 1. Over here I've got another two-step one. X to the fourth, x cubed, x squared, that's a GCF. They're all divisible by x squared. And then what's left, x squared plus 2x minus 8. This is that one factorable? Yeah, 4 and 2. So x squared multiplies to negative 8, adds to a positive 4. That is plus 4 minus 2. So that takes care of those. And then x squared minus 16, that's our difference of squares. X plus 4, x minus 4. Okay, now rewriting this with keep, change, flip, right? The top on this one, x squared, x plus 3, x minus 3 over x minus 3, x minus 1. Now if we multiply by the reciprocal here, the denominator is now going to be the numerator, so plus 4 minus 4. And this is going to be our denominator, x squared plus 4 minus 2. And now I just got to cross out everything that matches. I've got an x squared here that cancels this x squared. I've got a minus 3 that cancels this minus 3, and I've got a plus 4 that cancels this plus 4. And my final answer, x plus 3 and x minus 4 for my numerator, and my denominator, x minus 1, x minus 2, like that. All right, then the last two, again, I'll just start it out by doing keep, change, flip. 4x squared over 5 times 15 over 8x. If I multiply across the top, I've got 60x squared over 40x. 60 over 40, they're both divisible by 20, so that is 3 over 2. And then x squared over x leaves an x on top, so 3x over 2. And our last one, same idea. Rewrite it and keep, change, flip. 5x to the 6th, x squared y times y over 10x squared. If I multiply the numerators and the denominators, 5x to the 6th y, and then I've got a 10. I've got x squared, and x squared makes x to the 4th, and a y. Now if I approach everything individually, 5 over 10, they're both divisible by 5. That reduces to 1 over 2. X to the 6th over x to the 4th is x squared on top, and then the y's totally cancel out. So our final answer, x squared over 2.